Alright guys, your essential question for today is, how do we use the unit circle and unit triangles to calculate trig ratios? Your vocabulary includes the words unit circle and unit triangles, and just remember, you will have a quiz and a test over this material. Alright, let's go ahead and jump into today's lesson by reviewing a little bit of the topics that you covered in 10th grade math. If you remember, there were some special right triangles that you learned in 10th grade. One of those was the 45-45-90 triangle. And so what that means is that you have a 90-degree angle and that the other two angles are 45. What made this special was that you know that if in a 45-45-90 triangle, the two sides, the two legs, they were the same length. And let's say that I let the hypotenuse be 1, and in other words, this will be a unit triangle because the hypotenuse is 1. You could show with the Pythagorean theorem that both of your legs would be the square root of 2 over 2 in length. Alright, the other special triangle was a 30-60-90 triangle. And so if this was 60 degrees here, and then this is 30 degrees here, again, if the hypotenuse is 1 and it's a unit triangle, then across from the 30 you could prove that that is a half, and then across from 60 you could prove that that's the square root of 3 over 2. So those were some special right triangles that you learned, and we're going to apply these to actually finding the values of trig ratios. So both of these triangles are very important to know, especially for this class. Okay, let's talk about the unit circle. With the unit circle, you basically have, let me draw a better one, a circle that has a radius of 1. So there's my center, then the distance from all those is 1. What you notice is you can actually draw unit triangles on this unit circle because the hypotenuse, in this case, would be 1 in every single one of those because the radius is 1. So all of these would be how the unit triangles are actually on the unit circle. In fact, that's how the unit circle is formed. Alright, let's say I wanted you to find the exact value of cosine of 240 degrees. Well, the first thing that I would want to do is I want to find what quadrant this angle is, 240 degrees. Well, thankfully, that's between 0 and 360, so I know that 240 degrees is actually in quadrant 3. And if I were to draw that, let's see, there would be approximately 240 degrees. Alright, after I've found what quadrant it's in, I want to find the reference angle. Since we're in quadrant 3, the way that you find the reference angle in quadrant 3 is you take the angle and you subtract 180, and so then that would leave me 60 degrees. So this reference angle right here is 60 degrees. Alright, once I know my reference angle, what I can do is I can draw my unit triangle by simply dropping a perpendicular straight down. There's my right angle, and so this is 60, this is 90, so this is 30. Well, that's very crucial because now that I have my 30, 60, 90, I know that across from 30 would be 1/2, across from 60 would be the square root of 3 over 2, and then the hypotenuse, since this is a unit triangle, is 1. The next thing I need to do is I need to check my signs to make sure my legs are the right sign. Because remember, we're on the coordinate graph. So this x to the right is positive, this x to the left is negative. The y value up is positive, the y value down is negative. So if you notice, if this is my origin, since I go to the left, this 1/2 should be negative. And then right here, since I go down, this square root of 3 over 2 should be negative. The hypotenuse is always going to be 1, so don't worry about that. Alright, once I have checked my signs, now what I'm going to do is I'm actually going to find my trig ratio. Cosine is the same thing as adjacent over hypotenuse. So here's my reference angle, so adjacent would be negative 1/2 over hypotenuse, which would be 1. So negative 1/2 divided by 1 is negative 1/2. And then that would be the exact value for cosine of 240 degrees, negative 1/2. Now, one way you can check this is through a simple mnemonic strategy. Just remember a smart trig class. And what this means is that in quadrant 1, all of your trig ratios should be positive. In quadrant 2, only sine and cosecant should be positive. In quadrant 3, only tangent and cotangent should be positive. And in quadrant 4, only cosine and secant should be positive. Now, if you notice, since 240 degrees was in quadrant 3, only tangent and cotangent should be positive, so that just confirms that our answer is a negative. Remember, always check your signs. That's very important. All right, let's try another problem. It says use the unit circle to find the values of the 6 trig functions for a 135 degree angle. So again, the first thing I'm going to do is I'm going to see where 135 degrees is, and that would be in quadrant 2, somewhere approximately right there. So there's 135 degrees. After you've found the what quadrant it's in, you need to figure out what the reference angle is. So in quadrant 2, the way you find the reference angle is do 180 minus the angle, and so then that'll give you the reference angle, and in this case it will be 45 degrees. So my reference angle is 45 degrees. Once I've got my reference angle, I can drop my perpendicular. That's 90 degrees, so this is a 45, 45, 90. And so now that I know it's a 45, 45, 90, I can go ahead and label my sides. I know that these are going to be square root of 2 over 2, and my hypotenuse is 1. But make sure to check your signs. Remember, this is the origin. Since I go to the left, this is a negative. Since I go up, this is a positive. So my signs are right. Okay, now that I've got my reference angle, I've got my sides labeled, what I'm going to do is I'm going to use this reference angle as my angle to find all 6 trig ratios. So let's start off with sine. Sine would be opposite, so opposite of this reference angle, so that would be square root of 2 over 2 over 1. That just simplifies the square root of 2 over 2, so that would be sine. Cosecant would be hypotenuse over opposite, so that would be 1 over the square root of 2 over 2, and this is where your algebra skills are going to be needed, so you're going to do 1 divided by square root of 2 over 2. I'm going to stay change flip, so that's going to be 1 times 2 over root 2, which would be 2 over root 2, but you wouldn't want to leave it like this. You'd want to radicalize it, multiply top and bottom by square root of 2, so that'll give you 2 square root of 2 over 2, and the 2's are crossed out, just leaving you the square root of 2. That seems like a lot just to find cosecant, but a lot of that is algebra, so a lot of that's just reviewing of your algebra skills. All right, cosine is adjacent over hypotenuse, so that's going to be negative square root of 2 over 2 over 1, which is just going to be negative square root of 2 over 2, and I bet you can go ahead and guess what secant's going to be. Secant is going to be hypotenuse over adjacent, and so then that you can do the algebra, that'll end up giving you negative square root of 2. So we've got sine, cosecant, cosine, secant. All right, now let's do tangent. I'm going to do it over here. Tangent is going to be opposite over adjacent, so that's going to be square root of 2 over 2 over negative square root of 2 over 2, which that will reduce down to just be negative 1. And then cotangent, remember, that's just the reciprocal of tangent, so the reciprocal of negative 1 will still be negative 1. So these would be all 6 of my answers, and if you notice, we are in quadrant 2, and if you remember a smart trig class, in quadrant 2, the only thing that should be positive is sine, and if you look at all 6 answers, sine and cosecant, those are the only ones that are positive, so that's a good way to double check it. All right, let's see if I have another one. Okay, I've got 2 more. All right, it says find the values of the 6 trig functions for an angle in standard position if a point with coordinates 5, negative 12 lies on its terminal side. Okay, so notice that the point 5, negative 12 is on its terminal side. So let's figure out where that point is. So let's see where 5, negative 12 is. 5, 1, 2, 3, 4, 5, negative 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be 5, and then this would be negative 12. So here's my point right there. Notice that this is not going to end up being one of my unit triangles simply because once I figure out my hypotenuse, I'm going to notice my hypotenuse is not 1. Well, we do need to figure out that hypotenuse. here is my reference angle. Even though I don't really need to know what it is, I can just label that. That's my reference angle. Let's figure out what my hypotenuse is. So use the Pythagorean theorem. 5 squared plus negative 12 squared equals c squared. So that would be 25 plus 144 is equal to c squared. So that would be 169 is equal to c squared. And so that would just be the square root of 169. And I don't think that will simplify any 9, 10, because that's 16, but I'm just going to double check right quick if I can get it. Oh, yeah, it does reduce. My goodness, square root of 169 is 13, so that's going to be 13. Can't believe I forgot that one. Alright, so it's going to be 13 as my hypotenuse. So there it shows that it's not a unit triangle, and so it's not on the unit circle, but we can still find the 6 trig ratios from this because I know my reference angle is there, so my sine of the reference angle will be negative 12 over 13, so that means cosecant is negative 13 over 12. Cosine would be 5 over 13, so secant would be 13 over 5. Tangent would be negative 12 over 5, so cotangent would be negative 5 over 12. And that would be all 6 of my trig ratios. Alright, last one. It says, suppose theta is an angle in center position whose terminal side lies between pi and 3 pi over 2. If you haven't started learning these yet, you need to make sure that you know that pi is the same thing as 180 degrees. 3 pi over 2 is the same thing as 270 degrees. Pi over 2 is the same thing as 90 degrees. And 2 pi is the same thing as 360 degrees. So when it says the angle is between pi and 3 pi over 2, that means that the angle is between 180 degrees and 270 degrees, which means that this is in quadrant 3. This scenario is in quadrant 3. So it says that in quadrant 3, and let's just go ahead and draw my triangle. So in quadrant 3, I'm just going to draw my situation. This would be my reference angle, my perpendicular, and that would be my right angle. I don't know what these angles are, but I know that this is my reference angle, and it says that sine is negative 4 over 5. So sine is opposite over hypotenuse, so I know my opposite side of this reference angle would be negative 4, and my hypotenuse would be 5. All right, you could use Pythagorean theorem, but I do remember this one. This would be a 3, 4, 5 triangle, so I do know that this leg would be 3, but it's crucial that you see that this would be a negative 3, because remember, from the origin, if you move left, it's negative. You move down, it's also negative. So both of these values are negative. All right, well, that's all you got to do because you've got all 3 sides now. Sine is still going to be negative 4 over 5. Cosecant is going to be negative 5 over 4. Cosine is going to be negative 3 over 5. Secant is going to be negative 5 over 3. Tangent is going to be opposite over adjacent, so 4 over 3. Cotangent is going to be 3 over 4. Alright, well that covers all the material for this lesson, but in case you missed it, remember, a Smart Trig class will help you figure out what your sign should be for all of your trig ratios. Never leave a radical in the denominator. If you do, you're going to be in trouble on the test, so make sure that you simplify that. Don't leave a radical in the denominator. And that's it.